Okay, it looks to me like this problem is solved by separation of variables as opposed to using an integrating factor. Hopefully this is the correct interpretation of the problem. And if we factor out a y from this coefficient right here, it looks like this. And we can take this 3x dx to the other side of the equal sign. And if we actually wanted to say, what's the formula for dy dx? We could say divide both sides by dx to get dy over dx, and divide both sides by the coefficient of dy over here. That looks to me like a formula for the derivative with y in the denominator. Okay, but if we want to actually separate variables, we'll leave the y dy on the left side and divide both sides by 3x squared plus 1 over here. So there's the separation of variables test. And we're going to actually integrate both sides. So if we integrate y dy, we get 1/2 y squared. If I factor out the -3, I'm taking the antiderivative of x dx over 3x squared plus 1. I went over to scratch paper here to work on that. Using u substitution, you can see that this is what you get for that antiderivative. So here's that integral replaced with that expression. Multiply both sides by 2 to isolate y squared, distribute the -6, and you get -6 times c is another constant, so I just labeled it c sub 2. According to this problem, you want it to be f of x comma y equals a constant, so I just pictured transposing this to the left, and there's what I get. If you did actually want to solve for y, you could subtract, put it back the way it was and take the square root of both sides. To prove that that's a solution to the original differential equation, we should be able to take the derivative of this and end up with this. So the derivative, 1 over 3x squared plus 1 times, using the chain rule, 6x, and the derivative of, where are we here, of y squared with respect to x is 2y, y prime equals 0. Solve for y prime and you get that expression for dy dx, y prime. So that kind of proves to me that this is a solution. If I share my screen and go to Desmos, there's that f of x, which we think is the solution. I used k instead of c. And f prime of x is the derivative of that. That's this light green dashed line. And if I rewrite that as -3x over y times 3x squared plus 1, I get the same graph. And there's the equation of the tangent line right here using f prime. Can slide this around. That looks like a tangent line to me. And if I increase k, that graph goes out a little bit farther. So I'm kind of convinced that's the solution. I'm not sure why your website is telling you that's an incorrect answer, but I'll stop sharing. I'll give you a link to that Desmos graph, and hopefully you can figure out what's going on. Hope that helped. If you have any questions, post a comment.